Welcome to chemistry classes. In this video we are going to discuss about empirical formula and molecular formula. Okay, so here first we have to understand here empirical formula. Empirical formula mean simplest ratio of the different atoms in a molecule. Simplest ratio of number of atoms in a molecule, that is empirical formula. Empirical formula mean it is simplest ratio, and this ratio tells us the number of different atoms in a molecule. Okay, and here see here one example. Here we know the formula, molecular formula of carbon dioxide is CO2. Molecular formula of carbon dioxide CO2. Molecular formula of carbon dioxide CO2 mean this carbon dioxide contain one carbon and two oxygen. Carbon dioxide which contain one carbon atom and two oxygen atom. One carbon atom and two oxygen atom. We know one carbon atom mean one carbon. Look here. Carbon dioxide means it contains one carbon and two oxygen. So we can say here carbon dioxide it contains 1 mole carbon and 2 mole oxygen atom. Carbon dioxide it contains 1 mole carbon atom and 2 mole oxygen atom. 1 mole carbon means its mass 12 gram. We discussed before. 1 mole carbon means 12 gram carbon. So here we can say carbon dioxide it contains 12 gram carbon and 32 gram oxygen. 32 gram. We know oxygen it is 16. So 2 oxygen atoms. So 32 gram. Okay. So here carbon dioxide it contains 1 carbon, 2 oxygen, 1 mole carbon, 2 mole oxygen. 1 mole carbon means 12 gram carbon. 2 mole oxygen mean 32 gram oxygen. 1 mole carbon mean 12 gram carbon. Okay. 2 mole oxygen mean 32 gram oxygen atom. Okay. So look here. 12 gram carbon reacting with 32 gram oxygen. So using this, look here. 12, 32. So you can say using this ratio you can say 6 gram carbon reacting with 16 gram oxygen. Or you can say 24 gram carbon reacting with 64 gram oxygen. So using this one you can predict their ratio. Okay, so here carbon dioxide mean it contains 1 mole carbon and 2 mole oxygen. 1 mole carbon mean 12 gram carbon. 2 mole oxygen mean 32 gram oxygen. Okay, so 12 gram carbon reacting with 32 gram oxygen. So 12, 32. So using this ratio you can say 6 gram carbon reacting with 16 gram oxygen. You just make it half both. 12, 6, 32, 16. Okay. Or you can twice this. 12 times 2, 24. 32 times 2, 64. Okay. So using this ratio you can say 24 gram carbon reacting with 64 gram oxygen. Clear? Okay, so here we discuss here empirical formula. Empirical formula mean it is simplest ratio. It tells us different atoms. Okay, the ratio of atoms in a molecule. Okay, so how to find empirical formula? Next one we have to discuss here different ways, different steps to find empirical formula. To find empirical formula, first we have to find the masses of reactants which involved in a chemical reaction. We have to find masses of reactants and product, okay, that involved in a chemical reaction. Then this mass we have to convert into mole. First, we have to find masses of reactant and product during which involve in a chemical reaction. After that, this mass we have to convert into mole. Okay, this mole, using mole we can find mole ratio. Using mole we can find mole ratio. Okay, using mole ratio we can find formula. So we will discuss with this, we will discuss more examples. So you just remember, to find empirical formula we need masses of reactant and product. Masses of reactant and product which involved in a chemical reaction. This next step, this mass will change to mole. Using mole we will find mole ratio. From mole ratio we can find Okay, so here we discussed empirical formula and way to find the empirical formula. Okay, so here we have one question related to this. See here 32 gram. See here 32 gram sulfur reacted with 32 gram oxygen to form an oxide of sulfur. 32 gram sulfur reacting with 32 gram oxygen and formed an oxide of sulfur. So what will be the empirical formula of this oxide of sulfur? Oxide of sulfur. Okay, sulfur reacting with the oxygen form an oxide of sulfur. You have to find its empirical formula. So here these are the different steps. These are the different informations we need to find empirical formula. First we need mass, relative atomic mass. Okay, so in the question it is given 32 gram sulfur reacting with 32 gram oxygen. 32 gram sulfur reacting with 32 gram oxygen. We know relative atomic mass. We know relative atomic mass of sulfur. Sulfur relative atomic mass 32. Okay, similarly relative atomic mass of oxygen 16. Relative atomic mass of oxygen 16. Next we need to find moles, number of moles. How can you find moles? You can find moles, mass divided by relative atomic mass. We discussed before, number of moles is equal to mass over molar mass, or mass divided by relative atomic mass. Using this equation you can find number of moles. Okay, so what is the mass of sulfur? Sulfur mass 32 gram, oxygen mass also 32 gram. So here number of moles 32 divided by 32, answer 1. Here number of moles of oxygen 32 divided by 16, so here answer 2. Okay, so what is the ratio of sulfur and oxygen? 1 sulfur reacting with 2 oxygen. So here ratio is 1:2. This is the ratio. 1 sulfur and 2 oxygen. So what will be the empirical formula? Empirical formula S1O2. S1O2. S1O2 means SO2. So this is the empirical formula of this compound formed. Okay, so you can find empirical formula using this method. So here we need mass of reactant. Okay, no need mass of product, we need mass of reactants. Okay, mass of reactant, mass of sulfur and mass of oxygen. Then we will get relative atomic mass using periodic table. Relative atomic mass of sulfur 32, oxygen 16. Then we can find number of moles, mass divided by relative atomic mass, then ratio 1:2. Okay, here 1 and here oxygen it is 2. Okay, 1:2. So this is the ratio. So using ratio here 1 sulfur 2 oxygen, so SO2. This is empirical formula. Okay, here next question. The question saying an experiment shows that the compound Y, here one experiment, in this experiment this experiment shows that a compound the compound Y it contain 80% carbon, 20% hydrogen. 80% carbon and 20% hydrogen. Clear? So it's mean out of 100 gram compound, 80 gram carbon and 20 gram hydrogen. So one compound, in this compound carbon and hydrogen only, okay, the percentage of carbon by mass 80% and hydrogen 20%. So imagine the compound, it's 100 gram. So out of 100 gram, 80 gram carbon and 20 gram hydrogen. Find its empirical formula. This is the question. Find its empirical formula. So see here, to find empirical formula, we know these are the steps. We need mass, relative atomic mass. Then using mass and relative atomic mass, we can find moles. Using moles, we can find ratio. Clear? So let us see here, what is the mass of carbon and hydrogen? Mass of carbon, it is given here 80 gram. Mass of hydrogen 20 gram. Relative atomic mass from periodic table, you can find it 12 gram carbon and hydrogen 1. Relative atomic mass of carbon 12 and hydrogen 1. Number of moles, how can you find it? 80 divided by 12. And here it is 20 divided by 1. 20 divided by 1 means same, it is 20. Okay, when you divide 80 divided by 12, it coming around 6.67. So here this answer will be around 6.67. Okay, so look here the ratio is 6.67 20. This is the ratio. So we need to simplify this. So look here fraction. We have to simplify this. How to simplify this? You can simplify like this. Here it is 6.67 and 20. Okay. So here take the lower number. Which is the lower number here? 6.67. Take 6.67. 6.67 divided by 6.67. 20 divided by 6.67. Okay. So why we need to do like this? Because here fraction. We need to remove the fraction. Here it is 6.67 and here 20. Take the lower number. Take the less number, lower number. Which one is lower number? 6.67 is lower number. So take this number and divide both number. Okay, 6.67 and 20, both number divided by this 6.67 because it is lower number. So here answer will be 1 and here answer will be 3. You can check 20 divided by 6.67, answer 3. So here ratio is 1:3. This is the ratio. Okay, carbon hydrogen ratio is 1:3. So here C1H3, it is CH3. So this is empirical formula. To find empirical formula, these are the different steps. So here elements, mass, relative atomic mass, moles, ratio. After that, here only you have to listen here 6.67, there is fraction. We have to remove fraction. To remove fraction, take the lower number and divide all. Take the lower number and divide all. Okay, finally we will get 1,3. So here CH3 is the empirical formula. Clear? Okay, next one we have to understand here an experiment to find empirical formula. An experiment to find empirical formula. Okay, we know to find empirical formula we need mass. Look here, magnesium, its empirical formula MgO. Empirical formula for magnesium oxide MgO. To find this empirical formula we need mass of magnesium and mass of oxygen reacted. We need mass of magnesium and mass of oxygen reacted. Okay, so we can find this mass. We can find this mass with help of experiment. Okay, so see here, take an empty crucible. Take an empty crucible and measure its mass. Crucible, okay, this is one type of apparatus used in chemical laboratory. You can see here. So take one empty crucible and measure its mass. Imagine this mass is M1. Okay, so mass of empty crucible, it is M1. Then put one piece of magnesium into this crucible. Okay, again measure its mass. Okay, it is M2. So here we have here crucible with magnesium. Its mass is M2. So we need mass of magnesium and mass of oxygen reacted together to find empirical formula of magnesium oxide. So here we doing one experiment to find mass of magnesium and oxygen reacted. Okay, so see here, take one empty crucible and measure its mass. It is M1. And put one piece of magnesium into this crucible and measure its mass again, and it is M2. Now you can do here M2 minus M1. Okay, crucible with magnesium, that is M2, and this is empty crucible, only crucible, that is M1. M2 minus M1. M2 minus M1. This mass is this answer giving mass of magnesium. Okay, M2 minus M1, this is the mass of magnesium. Clear? Here next step, now we have the mass of magnesium. Okay, next we need mass of oxygen reacted. Clear? So here we have magnesium with the crucible and we have to heat it very strongly. Okay, we have crucible and magnesium and we closed this crucible with a lid and heat this crucible very strongly. Okay, and we have to open the lid of crucible frequently because to burn magnesium it need oxygen. Okay, in presence of excess oxygen, magnesium will burn. After burning, magnesium will change to magnesium oxide. So during burning, frequently we have to remove the lid of crucible to let in oxygen because magnesium need oxygen for its burning. Clear? So after complete burning, we have to cool the crucible and again measure its mass. This mass is M3. So here M3 means here crucible with magnesium we burn very strongly. During its burning we open the lid frequently to let in oxygen for better burning of magnesium. Okay, after complete burning of magnesium we measured crucible again with content, that is M3. Okay, then we have to after using these values, after deducting these values, we can obtain the mass of oxygen. Okay, also you remember mass of oxygen after burning it will increase. Mass of magnesium after burning, the mass of magnesium will be increases. What is the reason for this? Before it was magnesium. After complete burning, magnesium changed to magnesium oxide. Before it was magnesium 24. Relative atomic mass of magnesium 24. Okay. After complete burning, magnesium changed to magnesium oxide. Magnesium oxide. Here magnesium 24, oxygen 16. So its mass will be 40. So after complete burning, the mass of magnesium will be increases. Okay, and using this calculation we can find the mass of oxygen. Okay, we need already mass of magnesium. Okay, and after burning, this mass will be increases. Okay, so you deduct this mass with the previous mass, then we will obtain mass of oxygen. Clear? Imagine after our experiment, the mass of magnesium obtained 2.4 and the mass of oxygen obtained 1.6. Okay, and also look here, to obtain empirical formula, we know these are the different steps. We need the mass of reactants, mass of elements combined. We need relative atomic mass. We need moles. Using moles, we will find mole ratio. Using mole ratio, we can find empirical formula. So here mass obtained by this experiment, here mass of magnesium 2.4 and mass of oxygen 1.6. and relative atomic mass of magnesium and oxygen you will obtain from periodic table. You can use it. Magnesium 24, oxygen 16. Okay, then you will obtain here number of moles of magnesium 2.4. Look here, 2.4 divided by 24. 2.4 divided by 24, it is 0.1. And number of moles of oxygen 1.6. 1.6 divided by 16. 1.6 divided by 16. 0.1, 0.1. Okay, so here the 0.1, 0.1. To remove this fraction, we take 0.1 and divide all. 0.1 divided by 0.1, answer 1. Here also 0.1 divided by 0.1, answer 1. So this is the ratio, mole ratio 1:1. This is the ratio 1:1. Okay, Mg1O1, that is MgO, magnesium oxide. Okay, so this is the relative, this is the empirical formula of magnesium oxide, MgO. Okay, so we can use experiment to find this mass of magnesium and mass of oxygen reacted. After getting this mass, simply you can do this. Here we did, here 0.1. You need to remove fraction. To remove fraction, take one number and divide all. 0.1 divided by 0.1. Here 0.1 divided by 0.1. So 1, Mg1O1, that is MgO. I told you before, if you are different number 0.1 and 0.5, imagine different fractional number or different number. So take lower number and divide all. Okay, you have two number, you have the number of moles, there is fraction. Okay, if there is fraction, we have to remove fraction. Okay, if these numbers are different number, take the lower number and divide all. For example, you have 0.1, 0.5. Okay, after solving, you got number of moles like this, 0.1, 0.5. So what you have to do here, you have to remove fraction. How can you remove fraction? Here, take the lower number. Take the lower number and divide all. Okay. So here 0.1 divided by 0.1, okay, 0.1 divided by 0.1, here 0.5 divided by 0.1. Okay, this way you have to get a number without fraction. Here just I am giving one example. You have two different numbers, okay, 0.1, 0.5. So take the lower number and divide all. You have to do like this. Okay, in actual problem you will get the numbers after division, you will get real number. Okay, fraction will be removed. Clear? Okay, now we discussed empirical formula. Empirical formula mean the ratio of different atoms in a molecule. That is empirical formula. Next one we have to discuss here. Final formula. We can make final formula of the compound from empirical formula. From empirical formula we can find final formula. That's we have to discuss here. Okay, so here you know some compounds, their empirical formula and final formula it will be same. Okay, for example, ionic compounds. Okay, ionic compounds mean they have giant network structure. They have giant network structure. Even one molecule it contains many atoms. For example, sodium chloride. Okay, sodium chloride it has giant network structure. Okay, and there are many sodium and many chlorine atoms joined together form three-dimensional network structure. So you cannot say one molecule contain one sodium and one chlorine. Even one molecule it contains many sodium and many chlorine atoms. So in this case you can say the ratio of sodium chloride, in sodium chloride ratio of sodium and chlorine is 1:1. In sodium chloride the ratio of sodium and chlorine is 1:1. 1:1. This is the ratio of sodium and chlorine in sodium chloride. But you cannot say in one molecule of sodium chloride contain one sodium and one chlorine. It is wrong. Okay, so all ionic compounds we can say the ratio of atoms present. Based on this ratio we can say their final formula and their empirical formula. Okay, so here ratio of sodium chloride, ratio of sodium and chlorine in sodium chloride it is 1:1. So empirical formula is NaCl. Also final formula also same NaCl, because here we cannot say one molecule contain one sodium and one chlorine, we cannot predict it. Okay, similarly another example, magnesium oxide. Magnesium oxide it is ionic compound. Okay, ionic compound, they have giant network structure. Okay, and here ratio of magnesium and oxygen in magnesium oxide it is 1:1. 1:1. So here empirical formula and final formula of magnesium oxide it is MgO. So mostly ionic compounds, their empirical formula and final formula same. Next one we have to discuss here formula of molecular compound. Final formula of molecular compound. Okay, molecular compound. Example for molecular compound, ethane. Ethane is one example for molecular compound. Ethane it is organic compound. It contains carbon and hydrogen. It is organic compound. Also you can say it is hydrocarbon. Hydrocarbon means compound which contain carbon and hydrogen only. Compound which contain only carbon and hydrogen. Such type of compounds are hydrocarbon. Okay, so see here from this structure you can understand ethane which contain 2 carbon and 6 hydrogen. 2 carbon and 6 hydrogen. So you can say here C2H6. You can say here C2H6. So this is the final formula. When you take one molecule, okay, this is molecular compound, not we discussed before giant network structure. Ionic compound it is giant network structure, but it is molecular compound. Molecular compound means when you take one molecule of ethane, you can understand this only 2 carbon and 6 hydrogen. There are different type of instruments, spectrometer or spectroscopy. This type of study it helps to understand different type of atoms present. Okay, so when you study compound with help of this type of instrument, you can understand it contain different type of atoms present. So here we can understand here ethane which contain 2 carbon 6 hydrogen. 2 carbon and 6 hydrogen. This is 2 carbon and here 6 hydrogen, C2H6. So this is the final formula. So here molecular formula is better than empirical formula. Here molecular formula means final formula. Okay, so this final formula or molecular formula is better than empirical formula because it gives us more information about different atoms present.
Here final formula of ethane C2H6 mean it contains 2 carbon and 6 hydrogen. Only 2 carbon and only 6 hydrogen. Okay, that is final formula or molecular formula. Okay, so here this is molecular compound. It tell us the total number of atoms present. Okay, before in ionic compound we cannot predict how many atoms are there. It is based on only ratio of atoms. Okay, but here this is molecular compound, here C2H6. So look here, from formula here carbon and hydrogen, there is 2 carbon and 6 hydrogen. So here C2H6. So here ratio 2:6 mean 1:3. So CH3. So CH3 is empirical formula and C2H6 mean final formula. This is final formula or molecular formula, and CH3 this is empirical formula. Clear? So this type of structure giving you information about different type of atoms present in a molecule, and we can predict, we can say the final formula of the compound based on this type of structure. Clear? Okay, next one we have to discuss here how to find final formula or molecular formula. How to find? To find final formula, this is the equation to find final formula. Molecular mass divided by empirical formula mass times empirical formula. You have to remember this to find final formula. Molecular mass, you need molecular mass, also you need empirical formula to find final formula. Okay, so remember this, molecular mass, relative molecular mass divided by empirical formula mass. We will discuss what is empirical formula mass, but you remember now, molecular mass divided by empirical formula mass times empirical formula. Okay, based on this we have one question here. We have to find final formula of a hydrocarbon. A hydrocarbon means compound which contain hydrogen and carbon only. Okay, here in this compound, carbon, the mass percentage of carbon is 84.2. Okay, imagine out of 100, 84.2 gram carbon and 15.8 gram hydrogen. Okay, here 84.2 percentage carbon and 15.8 percentage hydrogen. Okay, this is the percentage of mass of carbon and hydrogen in this compound. Clear? So you have here mass of this compound, and you know relative atomic mass of carbon 12, relative atomic mass of hydrogen 1. You will get it from periodic table. Using this information you can find empirical formula. Okay, already we discussed different steps to find empirical formula. Here carbon, this compound which contain carbon and hydrogen. Okay, their mass is given here 84.2 and 15.8 already given here. Also we know relative atomic mass of carbon 12 and hydrogen is 1. Okay, then we have to find moles. We have to find number of moles. How to find number of moles? 12 divided by here mass divided by relative atomic mass. This is the formula to find moles. So here 84.2 divided by 12. Here 15.8 divided by 1. Okay, 15.8 divided by 1 means same number 15.8. Here 84.2 divided by 12 means 7.02. Okay, so this is the number of moles. These are the number of moles. Using number of moles, finally you have to get here ratio. You have to find ratio. So I told you before, you have two number. You have number of moles. These are fraction. Okay, you want to get ratio. What you have to do here, take the lower number and divide all. I told you before. So here 7.02, it is lower number, less number. So take this number and divide all. Divide all means 7.02 divided by 7.02, answer 1. Here 15.8 divided by 7.02 mean here 2.25. After division again there is fraction, so again you need to remove fraction, so you have to multiply with a common number. Here and here you have to multiply with a common number. Okay, when you multiply with 1 or 2 or 3, you will not get this type of real number. Okay, again it coming fraction. But when you multiply with 4 times 1 it is 4 times 2.25 it will be 9. After multiplying with 4 you are getting 4 and 9. Okay, now there is no fraction, so this is the ratio of carbon and hydrogen. Okay, 4 carbon and 9 hydrogen. So from ratio we will obtain empirical formula. So here you obtain empirical formula. Empirical formula is C4H9. C4H9. This is empirical formula. Okay, already we discussed how to find empirical formula. You need mass, relative atomic mass. You divide relative atomic mass divide mass divided by relative atomic mass. You will get this number. To remove fraction, take the lower number and divide all. Again there is fraction. So you multiply with a common number. Why I choose here 4? You try with 1, 2, 3. You will get fraction. Okay, after trying 1, 2, 3, try 4, you will get 4 and 9. Okay, now there is no fraction, so this is empirical formula C4H9. Also I told you this is the formula to find final formula or final molecular formula. This is the formula. Okay, here molecular mass of this compound already given here 114. It is given in the question 114. Okay, 114, and now we obtained empirical formula. It is C4H9. This is empirical formula. And what you need here? You need now empirical formula mass. What do you mean by empirical formula mass? You know empirical formula. This is empirical formula. Here carbon, 4 carbon, relative atomic mass of carbon 12. So 4 times 12 plus here hydrogen 1 times 9. So answer is 57. I will repeat once again. Your empirical formula C4H9. Okay, 4 carbon. So atomic mass of carbon 12. 4 times 12 plus hydrogen 1. Here 9 hydrogen. 1 times 9. So here answer is 57. This is empirical formula. Mass is 57. So you put over here 57. Okay, now all informations are here. 114 divided by 57 times empirical formula. Empirical formula is C4H9. So when you divide this, your answer will be 2. Okay, so multiply this here. So 2 times 4 it will be C8, and 2 times 9 it is 18. So this is your final formula of this hydrocarbon C8H18. Okay, C8H18. Okay, so this is the way to find final formula. First you have to find empirical formula. Okay, then molecular mass divided by empirical formula mass. This is the way to find empirical formula mass. Okay, relative atomic mass. Take your empirical formula, then here 12 times 4 plus 1 times 9, your answer will be 57. This is empirical formula. Clear? So these are the things we have to discuss in this video. Okay, you have one more video related to stoichiometry, percentage yield and percentage purity. You can watch it. Okay, and more problems related to this you can watch past paper related to stoichiometry. You can check playlist and watch past papers related to this one. Clear? So thank you for watching this channel.